Okay, so we're recording this meeting and let's get the notes as well. I'm going to start sharing my screen. That's the notes for this semester. So today I'm going to insert here and let's start another meeting here. 8/28/24. And today is Wednesday. Let's take a look at the syllabus. Okay, that's where we are right now. Next Monday is going to be a holiday, Labor Day holiday. So we are not meeting. What I want to cover today is going to be Excel graphs, units, and dimensional analysis. And whatever I left, whatever I started covering also, I'm gonna just go through it again. I think it's a very important piece of information, and I want to emphasize that the basic. Don't forget the basic. Don't forget the building blocks of physics, right? And they are the basic quantities, the primary. I call it the primary definitions, and the laws of physics, the laws of nature. Okay. Like I said, the basic quantities is something that basic quantities are the core quantities that are used in physics. These core quantities combined with the primary definitions and the laws of physics, okay, allows you to formulate most of what is known in physics. Most of what is known in physics. Okay, and I will keep on emphasizing that during, not just during this course, throughout the semester, but also during Physics 7 as well. And I'm going to repeat that here. Go. So think about the caveman, whenever they start to make sense of the world. Millions of years ago, right? The hominids start to come along. They evolved from the other apes. The chimpanzee, right, is our closest relative. And when they start thinking about the world, when they start to engineer their own world, they felt the need to come up with some basic quantities. Most likely the first one was the length, okay? And today we measure the length in terms of the SI unit that we call the meter. And if they were traveling on foot, and initially we were nomads, we didn't stick to a single place, right? They have to time how long it would take for them to walk from one place to another, right? So they came up with this idea of time. And today, the basic unit of time is the second. If they wanted to know how much meat, right? They would how much meat or how much food they would gather. I remember at that time we were still hunters and gatherers. We're not sedentary people, right? At that time. So if they want to know how much food they would gather, they would come up with this concept of mass, right? To say, look, you have this much food, right? That can be used to distribute to your people. And today the unit for this quantity, the mass, we call it the kilogram, which is also another SI unit. So those were the three, I would say the three most important basic quantities that we came about with. Later on, we came up with this other idea of temperature, this other concept of temperature. What is hot, what's cold, right? During this time, we were relying only on our senses to make this type of measurement, right? Initially, caveman, right? Caveman at the beginning felt the need to make sense of his caveman and woman, right? Caveman and cave woman. Let's make sure we mentioned the other sex as well, right? At the beginning, felt the need to make sense of this world. In order to do that, we had to invent some abstract concepts that were then implemented in practice. These abstract concepts today we call the basic quantities of physics. And they are the length, time, and mass. Let's say those are the three most important ones. The three most important ones. And they are so important that today we just take them for granted. They are so important. They are so important that today we take them for granted. Okay, just like they are just like second nature to us. They are just second nature to us. But then there are more, right? Later on, we came with other ideas. The idea of hot and cold, right? Which we call the temperature. Today, the temperature is measured in the SI units as kelvins, in kelvins, okay? And then there are three more that I'm going to write down here. The next one is the electric charge. And we use the unit of Coulomb. abbreviated by the letter C. That we're going to see in Physics 7. But before we get into electric charge, we're going to see another basic quantity that is a quantity of a substance. Okay? And that we quantify in terms of the mole. This is, I would say those two are recent. And by recent, I mean in the last 2, 3, 4,000 years. All those three here, maybe they came about in 100,000 years ago, maybe even more. I never saw any book documenting when those three important concepts came along, right? But I suspect that was at least, 100,000 years ago, we came up with all those three concepts, maybe even a million years ago. Let's see, we have 1, 2, 3, 4, 5, 6, and there is just one more left. Which is, let me organize it better here. Give a little bit more of space. Yeah, the last one, luminous intensity candle, the candela from candle. Okay, and then we have this last one, luminous intensity, the candela. Okay. 7, but don't forget, initially, all you have to memorize for now are those three. Later on, we're going to look into these other ones, the other 4. So let me emphasize those 3 here, length, time, and mass. Okay. For the sake of this course, okay, for the sake of this course, it is okay to believe that all these 7 basic quantities are independent of each other, okay? For the sake of, but don't forget, for the sake of this course, it's not what I'm saying here is not 100% true, okay? But for the sake of this course, it's okay for you to believe that. Okay, later on, we found out they are not independent of each other. Later on, someone that you have already heard of, okay, put in question the independency of those 3 quantities. And this guy is, you heard of him sometime. So what I mean that this is not 100% correct. Okay. Because just recently, and just recently, I mean 120 years ago, just recently, roughly 120 years ago, someone you have heard of demonstrated that this is not completely true. And his name is Albert Einstein. So think about that. We spend hundreds of thousands of years and even millions of years thinking that all those 3 quantities, even temperature, okay, all those 4 quantities, all those 7 quantities were independent of each other, One did not depend on the other. And then one day, someone comes along by himself, and he was the only one who came up with this idea. Nobody could figure out what he managed to figure out, okay? And he said, look, that's not true. That's not 100% true, okay? But for this reason, I say for the sake of this course, okay? For the sake of this course. Later on, when you get into Physics 7, then we're going to start worrying about that, okay? And he did that And he did that by formulating his theory of the special relativity. Okay? He found that time depended 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 depended, okay, on velocity. He found that the length, time, and mass depended on the velocity. That's why it's called special relativity. That's why it's called relativity, okay? He found that the measurements, these measurements depended on the referential we used, okay? Which could be moving at different velocities compared to another referential. Okay. So for the sake of this course, we can say that the length is the same whether your piece of ruler or whether your ruler is moving with respect to you or is at rest with respect to you. Okay, so that's what Einstein discovered at his time. Okay, if he discovered that this ruler here that I'm holding, the length of this ruler, not just the length of this ruler, but the length of any object, depends on its relative velocity. If this ruler is moving at a faster speed, it's slightly smaller than the length of the same ruler whenever it's at rest. Okay. So is that clear? Okay. So let's think about those quantities in terms of independent quantities. In physics 7, you're going to see that it's not exactly that. Okay. And then what else you need to know? You need to know those primary definitions here. Okay, there's an important difference between the basic quantities and the primary definitions. Okay, and I'm going to talk about that. The next idea is the concept of primary definition, position and force. Okay, the difference between the basic quantities and the primary definitions relies in their mathematical nature, okay? Mathematical nature. The basic definitions are quantities that in math we call scalar quantities. Okay? And whereas the primary definitions are vectorial in nature, are vectorial in nature, okay? So we have this important duality in mathematics, in math. We have this important duality of scalar versus vectorial. Scalar quantities versus vectorial quantity. And we are going to study those vectorial quantities in more detail. Okay, scalar quantities are the type of quantity that can be measured only in terms of its intensity, okay? Whereas vectorial quantities, they must be measured in terms of their intensity and direction. See the difference between vectors and scalars? Regular numbers, 1, 2, 3, 4, 5.2, etc., are scalar quantities. That's an example of scalar quantities. Now, things like position, force, velocity, and there are others, must be specified in terms of their intensity and their direction. Okay? So think about that. Most likely you have already seen vectors before, right? If you haven't seen, you need to start getting familiar with this idea of vectors. For a length of an object, the length of an object is only in terms of meters, right? Or centimeters, millimeters, etc. The mass of an object too. The mass of an object also, it can be specified in terms of kilogram, gram, right? Etc. And so it is the same applies to the other basic quantities. Okay. Now, the position of an object is always specified in terms of a length, right? Plus the relative position of this object with respect to a given origin. Okay? And this position is represented by an arrow. I'm gonna get let me show you here my illustrations. Let's see. Let me see if we have a good illustration for a vector here. And that's in terms of a practical sense. Okay, so let's see. Here you go. Okay, so in order for us to talk about the vectors, right, we have to have a Cartesian coordinate system. It's better if you define a coordinate system. The simplest of all coordinate systems is the Cartesian coordinate system, the axis x, for instance, okay? Which, by the way, notice that my axis has a unit of meter, and this axis and this axis x must have an origin that I can place anywhere. In terms, this axis must be, must be graduated, right? I can say that each graduation here corresponds at 1 meter, 2 meters, 3 meters, right? 4 meters, and so on. And the position of a given object in this axis, like this little blue object that I put it here, that I placed it here, okay? I call it x naught, its position. Its position is specified in terms, let me copy this one right here, in terms of a vectorial representation, which is represented by an arrow that goes from the origin of my axis, and I'm going to make my arrow. Okay, now that's good. Let's see. And I want to put it in a different color so you can see, yeah, red color. Okay. So what you see here is the very concept of a vector. Position is a vector, but there are other types of other types of vectors. Okay. Position of an object is defined in terms of the length of an arrow that goes from the origin of an axis to the position of where an object is. Okay? So keep that in mind. Okay, the length of this arrow is the scalar part of your vector. And the orientation of this arrow is the vectorial information of the vector. In this case, the vector is from the left to the right, but it can go other directions as well, because I'm displaying it in the one-dimensional coordinate system. This vector can also go to the left, either to the left or to the right, right? If we start talking about the two-dimensional space, then this idea of vectors become a little bit more generic, okay? Just like here you go, the two-dimensional space, x and, no, not this one. I want to go to the other one. It's further down the line here. This right in here. Okay, so here is my x and y axis. I'm gonna copy it and place it here. Copy and place it here. But here is gonna put it as y. Okay. Now the position of a given object, of this object, for instance, I'm gonna put it, get another one here, and I'm gonna put just one object. Okay, get rid of the thing here. In a two-dimensional space, I'm gonna need this one. I'm gonna use it as my vector. The two-dimensional position of this object can be represented by this arrow here. And I'm gonna put it in red color, a little bit thicker. Okay, so you got the basic ideas of vectors. Okay, this vector can be in this direction, can be in this direction, in this direction, in this direction, and so on. Okay. Examples of vectors in physics. Examples of vectors in physics. Okay, position. I already mentioned that to you. Those are primary definitions, right? Primary definitions. The primary definitions are vectors, position, and force. Okay? You can only talk in terms of force if the force is upwards, downwards, sideways, okay? Force is not a scalar quantity, it's a vectorial quantity. Okay, and then you also have the secondary definition that we're going to cover very soon. You know, displacement is a secondary definition. Displacement is a final position minus initial position, okay? Since position is a vector, when you subtract one from the other, you still get a vector. And then after the secondary definition, we're going to have a tertiary definition, which is the velocity. The velocity depends on the displacement divided by amount of time. See that? And then there are more. There are more. Acceleration is another one, okay? Other vectors, okay? Other vectors. Acceleration. Okay, and if you have seen physics before, linear momentum, angular momentum, etc. We're going to see all those vectors but at this point in time, the only two vectors that you have to worry about is those two, position and force. Okay, 923. So I'm just elaborating what I mentioned to you before. Okay, here you go. I can even come up with scalar. There's scalar. Okay, and here there are vectors. That's the difference between the primary definitions and the basic quantities. Any questions? How many students we have? We have 26 so far. It's 9:24. We're still in good shape here. And that's what I want to mention, to tell you about those core principles, those core principles of physics. We are not ready. I'm not ready to introduce you the laws of physics yet. Okay? We're going to see them very soon. Laws of physics. Let's see. Yeah, here you go. But I'm going to elaborate just a little bit with the laws of physics here. What about the laws of physics? What about the laws of physics? Or the laws of nature? Okay. There are synonyms for this. Okay. The laws of physics. There's a difference between, there's an important difference. There is an important difference between the laws of physics and the laws that we impose to each other, right? And the laws in jurisprudence and the laws in jurisprudence. There's a very important difference between those two laws. The laws that we impose to each other. The laws of physics are the laws that nature obeys. Okay? whereas the laws of jurisprudence, right, are the laws that we we as citizens, right, must obey. Otherwise we can get into trouble, right? We can get into trouble. Do you see the difference between them? Nature, they do automatically obey the laws of physics. In other words, nature automatically obeys the laws of physics. Nature is incapable. Nature is incapable of breaking the laws of physics. Whereas we as citizens, right, we can get away. We may get away with breaking the laws of jurisprudence, right? May get away. If we don't get away, we just get arrested or we get sued, right? If we do not get away, if we do not get away, right, we risk being sued or even incarcerated. Okay, so that's an important distinction between the laws of nature and the laws of man, right? So the laws of physics. So the laws of physics is a statement, either mathematical or you know, or spelled out in words. Is an encompassing statement. Let's put it like this way: an encompassing statement. Statement that applies in many situations. Okay, so that's how we build physics. Okay, there are very few laws of physics. There are very few laws of physics. The greatest contribution you can do to science, contribution you can do to science is to formulate a new law of physics. So when Einstein came up with that crazy idea that length depends on velocity, mass depends on velocity, time depends on velocity, he managed to prove that by formulating a new law of physics. Okay, so when Einstein came up with his new crazy idea, and crazy because nobody would believe him, crazy because nobody would believe him, it was very difficult to accept, right? The consequences of this new law, consequences of this new law, of his new law. That time, length, and mass were dependent on the velocity, on the relative velocity, okay? Velocity he determined this from one of his laws, of his laws, okay? So that's what I want to tell you about the core principles of physics. Keep that in mind. Okay, and every time that you are struggling with physics, just go back to the basics. Go back to what I mentioned here. Okay, that helps organize the mind, the brain. Okay, any questions before we move forward? Okay, so now let's talk about units of physics. Keep in mind that what I mentioned about the core principles of physics, right? The building blocks of physics is something that it's not in any book. Okay, you're gonna find only here in this formulation here that you are seeing. Okay, now when it comes to units of physics, every book has a discussion on that. Okay, every quantity, here you go. Every quantity and definition in physics have units. Okay, units exist to distinguish one measurement from another. And even more, units also exist to quantify, okay, a given, quantify a given quantity and a given concept, okay? Quantify a given concept. It's possible to make mathematical operations, okay? Between like and unlike units. It's possible, but not all the time. But some of these operations might not be allowed, and you're going to understand might are not might not might but are not allowed, especially, okay, between different units. Has. Okay, this just think in terms of think in terms of, you know let's see, units. Okay, different units in physics behave just like different fruits. Okay, you can sum one apple with another apple, right? And obtain two apples, comma. But you cannot sum between one apple and one orange. Okay, you don't get two apple oranges. Okay, in this case, you don't get two apple oranges, right? Let's put this. There's no such a thing like two apple oranges. Instead, you still have one apple and one orange. Okay. The same thing applies to units. The same thing applies to units. Okay. So let's look at an example. In other words, comma, you can sum or subtract 1 meter from 2 meters. Okay. If you sum and so let's put yeah. I'm gonna put it right in here. So I'm gonna put it 1 meter plus 2 meters is 3 meters, right? And now 1 meter minus 2 meters is minus 1 meter, right? But you cannot sum and subtract 1 meter with 3 seconds. There's no such a this type of operation. This type of operation between different units are not allowed. Okay? You cannot sum or and subtract 1 meter from 3 seconds from let's say 1 meter from 3 seconds or 3 kilograms or 3 kilograms. These types, right, of operations, these types of operation, and I mean sum and subtraction, okay, among different units are not allowed, are not mathematically allowed. Okay. But it's a very important distinction between fruits and units is that, however, unlike the example of fruits, we can multiply or divide like and unlike units. Okay? We can do that. For instance, consider a square of 1 meter of size, okay? If you want to find the area of this square, all you have to do is to multiply each separate measurement, or, okay, area equal area equal area is equal to 1 meter. Oh, lowercase. What's going on here? Okay, let's see. It's gonna work now. Huh. People, that's so odd. Let's see what's going on. Oh my goodness. It's not behaving properly for some reason. So let's try it. Let's try it again. Every now and then my computer does something like that. Area, okay. Now it's working. Area equal to 1 meter times 1 meter, right? See, we're multiplying 2 units. In this case, those are the same units, right? But you can have the same thing for different units. Multiplying 1 meter with 1 meter, we get 1 square meter. Font, superscript, okay? 1 square meter. Yeah. And what about I keep on doing that. Let's see. What about dividing 1 unit by another? Okay, so here you go. We may have, it's possible to have something like, 1 meter divided by, let's say, 10 seconds. It's possible to have something like that. Okay. And when you do this calculation, you get the 0.1 meters per second, which, by the way, is the unit of velocity or speed, of either velocity or speed, and or, which is the unit of velocity and or speed, okay? There's a difference between the concept of velocity and there's a difference between the concept of velocity and speed. They are not the same unit of velocity. You cannot sum different units, but you can multiply and divide different units. Okay? In other words, you cannot sum and subtract different units, but you can multiply and divide different units. Okay? Those are the so-called compounded units. The so-called, what I call compounded units. Students coming in. What time is that? 9:42. Okay. In our labs, we will always, use the SI, National System Units. Okay, and the SI unit again is the meter, the kilogram, the second, etc. Always use the SI units and their combination. Meter, the kilogram, the second, the meter per second, okay, etc. So when you combine one unit with another, we do what we call a dimensional analysis. Okay, dimensional analysis is a dimensional now means units, analysis of the units. That's what it means. Has nothing to do with the dimensions, 1, 2, 3 dimensions. No, has not. Dimensional analysis here is in the sense that the dimension is defined as the unit. Okay, or unit analysis, right? Okay, this is a very useful technique that we use to find out whether we are doing a calculation properly, a given calculation properly, okay? So here you go. Let me give you some examples here of compounded units. You already saw some. Let me give you more. Area, meter square, speed, velocity, meters per second, volume is cubic meter. But then you have that concept of acceleration that you're going to see soon. The acceleration has a unit of meters per second square, okay? The unit for force is a compounded unit of that involve the kilogram, the meter, and the second. Kilogram meter per second square. This unit is so important, but so important that we give it a special name. We call it the Newton, which is abbreviated by the letter N. We're going to use those things so frequently that you're going to end up memorizing them, okay? So make sure you start memorizing, at least for the force, kilogram meter per second square. The unit for force, the unit of force is determined from one of the laws of physics, Newton's second law. The name of this law is Newton's second law. Okay. 9:46. Any questions before you go forward? Okay, if you don't have any questions, let me take attendance. Today is supposed to be a lab meeting, okay? And 28, Audrey Agnew, are you there? Let's see. Okay, right in here. Yeah, okay. Let me get the chat box here. Yeah. Yeah, I will. I will post, yes. The Gabriel, right? The Contreras is asking whether I'm gonna post the recordings. It's gonna take some time because the recordings, they don't become ready immediately. So maybe, it takes some time for it to load into my hard drive because the recording is very long, 2 hours, 3 hours long. It takes lots of space in my hard drive. So you may expect it like in 24 hours. Within 24 hours, I'll try to post it as soon as possible. And then I provide you with the link. Okay, Gabriel? Okay, so Audrey, are you there? I see Audrey here in my list, but I don't hear from Audrey. Okay, I'm gonna put a little star here if I don't hear from you, and you're listed here in my list of participants. I just put, and you don't answer for my roll call. I will put a star here in your cell. Now, Audrey Aguilar, are you there, Audrey? Audrey Aguilar. Okay, I'm gonna put that. Matthew Aguirre Mata.
Good morning, Professor.
Okay, thank you, Matthew. James Monroe. Let's see.
Good morning.
Darius, right? Darius
Yeah,
James
yeah.
Monroe. Okay. Thank you, Darius. Next is Edito Bonilla Moreno.
Here.
Thank you, Edito. Naila Buenrostro. I don't see Naila here. Yeah. Next is Jazzy Castellano. Thank you, Jazzy. Gabriel Contreras.
Here.
Thank you, Gabriel. Okay. Liliana Cortés.
Here.
Thank you. Juan Salvador Escalera. Okay, thank you, Juan. Molly Fitzgerald.
Here.
Thank you. Josh Gonzalez. I don't see Josh here. Audrey, okay, Audrey Aguilar. Thank you, Audrey. Okay, I haven't heard from Josh. Next is Henry Kim.
Here.
Thank you, Henry. Ruth Manduhano. Ruth. I don't see Ruth either. Okay. Noemi Martinez. I see Noemi here in my list. Are you there, Noemi? Okay, I'm gonna put a star here. Danae Miller.
I'm here.
Thank you. Ramon Olivares.
Here, Professor.
Thank you. Tyler. Taylor, right?
Here.
Thank you. Alexis Quijada. Audrey. There's this other Audrey here, right? Alexis Quijada. Let's see if Alexis is here. Alexis is not in my list. So let's put a 0 here. Stephanie Ramos.
I'm here, Professor.
Thank you. Jeremiah Reyes.
Here.
Thank you. Sean Rosario.
Here.
Thank you. Next is Evelyn Rizzo Valley. Evelyn, I don't see Evelyn. Yeah, I don't see Evelyn here. Ali Dominique Standard.
I'm here.
Thank you, Ali. Jason Strait.
Here.
Thank you. Elena Trujillo. Let's see if Elena is here. I don't see Elena in my list either. One more, Jason Valadares.
Here.
Thank you, Jason. Stephen Vadhapali.
Here.
Thank you. Laurel Williams.
Here.
Okay, we're there. Okay. Nuhamin. Okay, thank you. Alia Trinity Zavala.
Here.
Thank you. And let's see, is Matthew Richard there? Let's see. I don't see him here. Richard. Okay. Yeah. Okay, not here. Good. So let's see how many we have here.
Hi, Professor. I'm here.
Yeah. What's her name?
Elena.
Elena. Wait a minute.
Yeah.
Let's see. Elena. Where's the last name? Okay, Elena Trujillo. Okay, and Evelyn Rizzo Valley. Is she here? Let's see. There is Alexis. I don't see Alexis. There's one issue. Noemi. Are you there, Noemi? Yeah. Okay. So total is 25. We have.
Hi, Professor.
Yeah. Who is that?
This is Brianna Carrillo. You didn't call my name, but I joined late.
Okay. Did you just add your name to the course?
Yes.
Okay. So let me write that down here. Yeah. Is there anybody else who I didn't call the name? Carrillo. Carrillo. Brianna,
It's
right?
with the double L O.
Double
Carrillo.
L O, right?
Yes.
Oh yeah, that's right. Double L O. Brianna. Yeah, and okay, that's the first time you're coming, right?
Yes.
Okay, thank you. Good. So it's 9:55 right now. Let's take our 15-minute break and break from 9:55 to 10 a.m. Okay, I see you in 15 minutes. No, stop recording. Okay, I am back here. And let me reply. Let's see, let me share the screen first. There are a couple of questions here, right? There is no, let me get organized here first. Okay, let's see. Okay. Was wondering what the lab was that's due today at 12 p.m. Is that unlikely? Okay, no, all you have to do for today's lab is to be present. Okay, that's what's due today, your presence only. There's nothing, there's no lab report for today, okay? So don't need to worry about that. Sorry, step down. And then we also have Noemi. Let's see, Noemi Martinez. Okay. And now we have 27 students. Yeah, okay, good. So going back here, so there is no lab due today, okay? Only your presence, only your presence is due today, okay? So what I usually do, these are just some introductory things that must be done before we start the actual lab. Okay, there is no lab report for today. There's no lab report for today. What we're going to do is just get you familiar what we are going to do today. I will just spell out what we will do for the lab during the semester. Okay, so what to do today. But you need to be here in order for you to get the credit for today's lab report, for today's lab activity, okay? You, however, let me put right in here. However, you need to be present to get attendance for today's lab activity, okay? I was wondering where we would find these notes that you are taking now. Oh yeah, I'm gonna post them. Okay, I'm gonna post those notes. I always post my notes, so I can say. And I shouldn't post the notes of Monday, but if you go to, let's see, if you go to Canvas, you are going to find my notes of the fall 2023. Okay, when I taught this course back in the fall 2023, I would type the notes, turn into a PDF file, and post them. See that? So this one I already posted there for the whole semester. Okay, what you see here is for the entire semester. So how many pages do I have here? So when I taught this course, 156 pages. See that? Formulas, derivations, all that stuff, are here. Whatever I tell you, I am a type of obsessive. I have this obsession of documenting everything, everything that I say in the classroom, I like to type. And I need to start looking into that dictation software, right? So I don't need to type anymore. I need to start using the dictation software. So yeah, I'm gonna post those notes that I am typing right now. Okay. And
Professor, I have a question. Sorry.
yeah,
I just saw that on Canvas you did upload a thing that says lab for today. Is that the thing
where?
we're getting? Because it just says like we have an assignment that's due today at 12.
Yeah, you're talking about, let me see, in order to avoid any further confusion, let me do something. It's a lab, right? Is this one here?
Yes.
Let me
Yeah, it
see.
says 100 points. I just want to make sure, like,
Yeah. Let me do something here. So what I meant is that for this one, you need to be present. Okay, so let's see, how do I fix that? It must
oh,
be,
okay.
let me see how I fix that here. Okay. Yeah, that's the deadline. Let's see, edit. Okay. I'm gonna put unfortunately the thing is in Portuguese. I want to put it in English. Yeah. Let's see, where is that? Huh, strange. Where do I access the date of the thing? Just supposed to be here, right? Here? No. Well, I'll have to fix here. There's nothing, nothing due today. Okay, I'm just trying to remove this date here, but I can't for some reason. At least I cannot find it right now. Let's see, is it possible it's here? Just supposed to be here. It's not that saying view online points lab report. Yeah. What I'm gonna do? I'm gonna do the following. I'm going to remove this one. Okay. So you don't have to worry about. Okay, let's do that. And then here you go. Now it's okay, right? Yeah. Attendance. Well, I didn't find that attendance. Let's see. Let's see if this one here. Items speed created. Yeah. Well. Okay. I hope I solved the problem. I solved the problem now. But thank you, Sean. Now let's go to our notes here. Okay. What I want to do and get my notes. Oh yeah, let me cover some of other types of units. Centi. Okay, there are other ways. There are other ways of expressing your measurements, right? For instance, 1 meter can be written in terms of 100 centimeters, right? Or let's say 1,000 or 1,000 millimeters. But don't forget, this is the SI unit. This is the SI unit, right? Not the centimeter, not the millimeter, right? But what I want to tell you is about those things that go before a given measurement, okay? And you must memorize those. There's no other way. You gotta memorize them. And most likely you already know about it. Okay, and here you go. Kilo, which is represented by the letter K, it's just a short for 1,000, for the number 1,000. Centi, which we represent just like the letter C, is 100s, okay? 1 divided by 100. That's what centi means. 1 divided by 100 is 0.01, which is 10 to minus 2, okay? Milli is 1 divided by 1,000, which is 0.001 or 10 to minus 3. And then there are more, okay? But those are the three that we are going to use the most, okay? If you want to learn a little bit more, let's see, I'm just going to put a little space here. And then we also, for smaller quantities, right? We have the micro too, which is 1 divided by 1 million. The representation of the micro is the Greek letter for the M, the corresponding Greek letter for M, okay? And I need to change, which is the mu, we call it mu, okay? That's the representation. Kilo is K, cent is C, milli is M. Oh, don't forget, don't confuse the M of milli for M for meter, right? Watch out for that. Micro is the mu. Here is 10 to minus, let's see, 1, 2, 3, and that's 10 to minus 6. Okay. 1, 2, 3, 4, 5, 6. Okay, like that. And then you have more, but don't forget, those are the three more important ones that you have to know by heart. The rest you can take your time to memorize. You have nano. The nano we represent by the letter N. Okay, and that's 1 divided by 1 billion. And instead of 10 to minus 6, it becomes 10 to minus 9. Okay? All those things you can find in the internet, and we give it a name. Let's see, Wikipedia has those things. Wikipedia, we call them, no, let's see. No. Okay, it's a prefix. Okay, we call it a prefix. Let me get it, the one in English. Okay, yeah, here you go. Okay, nano is the unit prefix you want. Okay, here you go, unit prefix. You have all sorts, and let me write that down here. Of expressing your measurement. Your measurement. You do that in terms of a unit. You do that in terms of a unit prefix. Okay, example. 1 meter is equal to 100 centimeters, which is equal to 1,000 millimeters. And here are the most important ones. And then there are others. Like I said, if you want to know all of them that are available out there, just go to the Wikipedia unit prefix entry. Okay. So you can see we have a deca. We don't use deca too much. Okay. Hecto, we don't use hecto too much, but we do use kilo. We do use mega. Mega is a million. Giga, like gigabytes in your computer, right? And then now we are getting terabyte hard drive, right? Storage, terabytes size storage computers, but among all of those, the kilo, the centi, and the milli are the most important ones. Here's the micro, the nano, and then we have the pico as well. Okay, let's put that pico. And we abbreviate by the letter P. I'm not going to keep on writing this big number anymore, right? It becomes very, very inconvenient to do that. And then it becomes more convenient when we just write that down in terms of 10 to minus 12. Above that, I'm going to put, we get mega, right? Mega, like megabytes, right? Mega is a million. Okay, 10 to minus 6. No, 10 to plus 6. More students coming in, good. Then next, after mega, we have giga, abbreviated by the big G, right? And that ends up being 10 to the 9. And then we also have tera. But again, sometimes can be very daunting to memorize all of that, right? But start with the ones that we use the most. Then the one that we use the most, I'm going to emphasize here is a boldface. Let me see, did I forget to turn on my recording here? Let's see, are we recording? Yeah, we're recording, that's good. Okay, so that's one important piece, another important piece of information that you have to memorize. Okay. And now we're going to do an example. It's a very important example, okay? How do you express is that convert, okay? 1 square meter. That's something that can feel a little bit challenging, right? How do you express, convert 1 meter square in terms of centimeter square, okay? Think about that. How do you do that? I'll give you like 3 minutes and then I'm going to provide you with a solution. And by the way, the solution is in my notes of last year. But try to do that on your own before you look at the solution, okay? 28, let's see, you have until 10:30 to solve this little problem. Start. Okay, so 1 meter square, right, is going, we have to change this meter square in terms of centimeter square. And 29. There's a very simple and easy mathematical way of converting this measurement into this other one. Okay? And logical too. It obeys a logic. We want to express this quantity in centimeters square. How do you do it, right? Okay. If it were just 1 meter, you already know, right? If you want to convert 1 meter to centimeters, by straightforward definition is 100 centimeters, right? That's the definition. Okay. Now, 1 meter square, how is it written down? How can it be written down? It can be written down in terms of the meter alone squared, like that. Okay? Right? And now what do? You just go ahead, get this relationship that you see here, there upstairs, and plug it here inside. And let's not forget that what you see here, what is between parentheses, is not just the meter itself, but it's also the implicit number 1, right? So all you have to do is to substitute 1 meter right here. And then what you get, I'm going to substitute 100 centimeters here inside, okay? And then we get this big number, right? 100 is 10 square, okay? We don't need the number 1 anymore. Then what we do here, we have, when we square everything, we end up with something like that. 10,000 centimeters square. Okay? Which is also equal to centimeters square. You do the same if you want. What if you want to do all over in the other direction, right? How do you express, let's say, 1 cubic centimeter in terms of cubic meter? Now it's all the way around, right? 1 cubic, I want 1 cubic centimeter here in terms of cubic meters. So we start with cubic centimeters right here. We do know that 1 centimeter is equal to 10 to minus 2 meters. 10, oh. Let's see what's going on. Okay. 10 to minus 2 meters, like that. Right? All I'm doing here is passing the 100 to the other side. Even better. You know, let's do like that. 1 divided by 100 meters, right? And now that I know that 1 centimeter can be written down like that, okay? So we repeat what we did before. Separate, put the centimeter alone here. Don't forget to multiply by 1, the one that is implicit, right? I copy this centimeter, this relation that you see here, I copy it right here. And then I raise the cube of everything, right? The cube of that is going to be what? Is 10 to minus 2 meters, 3 times. 3 times. I'm doing this additional step that I didn't do before, right? And then what you get 10 to minus 6 meters, cubic meter, like that. Okay? That's what 1 cubic centimeter is all about. Okay? And now you can start solve your problems on your own. Here, you know, just practice there at home. If you cannot find out how to do it, let me know. How to convert a square meter into cubic feet, into square feet, okay? How to convert square meter into a square inch and vice versa. The principle is the same. How to convert 1 kilometer per hour into meters per second and vice versa. Okay. And then there are a bunch more of exercises that I can do for you, like how to convert 1 mile per hour into meters per second, right? And vice versa. Okay. And that's what I want to do for this part. So that's attendance, I believe. Let's see. Okay, so now what I want to do, check your syllabus. I need you, let's see, for the lab, for the lab, you will need access to Microsoft Excel and Microsoft Word, okay? Everybody has access to Microsoft Excel and Microsoft Word in their computer. The college, provides with a license for this software for every student, okay? And you need to do that. You need access to that because you need access to these softwares because we'll be plotting. We will be plotting graphs with them. Yeah. Ideally, you should have the software now, Sean. That's why I'm asking you. Who has Excel software there in their computer? Let me check one by one. Insert here Excel. Okay. So I have an idea. Audrey Agnew, do you have Excel software there in your computer?
Not at the moment.
No. Okay. Try to get a license from LA Harbor. Okay. And see if you can get it right now. It's possible to do that right now. Okay. Let's see. Audrey Aguilar, do you have Excel installed in your computer? No. Okay. So let's see. Matthew Aguirre.
Yes, I have it open right now.
Oh, you do have. Okay, that's good to know. Darius, do you have Excel installed on your computer? Yes. Okay, good. Edito Bonilla, do you have Excel installed on your computer? Browser version is not Excel, right? I'm not sure if the browser version is Excel. I believe that the browser version is another software. But you can try. I have never used the browser version, so I do not know how it works. Are you sure it's Excel or something else? Google has a browser version that's not Excel. It's something else. I don't remember right now. But tell me, is that Excel, actual Excel, Jeremiah? Yes. Okay. Okay. Try it. Let's see if it works. I'm not sure if you're gonna have everything that Excel has. Okay. So let's see. Edito, are you there, Edito Bonilla?
Yes, I
Yeah,
don't have it installed.
You don't?
I don't.
Okay. Can you check LA Harbor website? Check how you can download a license for you. Okay. The college
Okay.
provides this thing for us. Let's see. Naila is here. No. Jazzy? Nope, you don't have it. Did you try to get a license for you from the site? I know it's possible, Ramon. I do not know how because I have my own personal I have my own personal Excel here. Okay, but let's see. Let's see here. Let's take a look here. No, but I can't get it from the school, even if this college is not my friend. Okay. Okay. Oh, well, if you are registered for my class, right, you should be able to get this software. Okay, Gabriel, if you're registered for my class. Let's see if we can find something here in the internet. How to get an
Professor,
Excel.
off the Outlook email, I can go to the apps and use the Excel on the browser. Is that all right?
Okay. Okay, yeah, but I believe you can also download it to your hard drive and even get a license, okay, a license code. But yeah, if that's an option, right? At LA Harbor. Let's see. Let's see here. LA Harbor, blah, 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 determine license type, product. Microsoft. LA Harbor, Los Angeles Harbor. Check Microsoft license. The LA Harbor license. LA Harbor license for, yeah, so let's see, Microsoft Excel. Let me do that myself. That's a very good, let's see, where do you go from here? There might be a place here, OneDrive, groups. Let's see. Oh yeah, here you go. Right here, let's see. I never use that because I have that installed in my computer, but okay. Think novamente my start why it's not working here? Let's see. Let me get out of my software. Let's see if that's the problem. He doesn't let. Are you having this problem as well? For some reason, I cannot run here in my hard drive. Excel. Let's see. Let's try Word. Yeah, it doesn't let me. Huh, interesting. Are you having the same problem? Let me go back and let's see. Wait, this one here. Okay, so Gabrielle, do you have Excel in your computer? No, right? No. Liliana?
Yes,
Yes, you do. Okay, that's good. You have your own personal license or you got that from the college, Liliana?
from the college.
From the college. Okay, so you might want to share with us how you managed to do that.
I just like someone in the comments said, I logged in using my school email and
Yeah.
the application on my computer and it just logs in and lets me use it.
Uh-huh. Okay, so you just go to the email, right? Just like I did, and right in here you have those options, right?
Yes.
Okay, and then you just click on Excel and Word, and it comes online for you, right?
Yes, I haven't tried fully Excel, but
Uh-huh.
Microsoft has worked perfect for me.
Okay, let me try this one here. For some reason, okay, let's see. Yeah, well, but this is not Excel, definitely. Okay, so that would be the way for you folks to try there on your side. Okay. And you can get it through the school. If you log into your Microsoft account with your school email, Excel should work as well. Okay, I tried what and I was able to get it. Okay, great. Sean, right? Okay, so let's go one by one. One, escalera. So we're getting there. I believe in signing. So did you manage to access Excel, Juan? I presume that you managed to do that, right? And Molly can get, okay, Molly, good. Henry Kim,
Yeah, I did. Yes.
You did? Okay, good. Next is Noemi. Hi, Noemi. Did you manage to get Excel? Yes. Okay, good. Okay, we're getting there, right? Danae Miller.
Yeah.
Yes,
Yes,
great.
I have.
We're getting there. Okay, things are fitting. Now the puzzle is fitting together, right? Everything is coming together. Ramon Olivares.
Yes, I'm signing in right now. I got access to it.
Okay, that's good. Taylor Narun Forn. Did you manage to get Excel there in your computer?
Yeah, I'm downloading it right now.
Okay, good. So you are downloading, right? So it's not just through the browser, but you'll be able to install it in your own computer, right, Taylor?
Yeah.
Okay, that's good. Stephanie?
Yes, I was able to sign in and then use it from the browser.
Okay. Jeremiah? Hello, Jeremiah. Are you there? Okay, let's go to the next. Sean. I tried. Okay, Sean already, yes, right? Jeremiah, yes, as well. Okay, most of you apparently. Ali, standard.
Yeah, I have it.
Okay, good. Jason straight.
Yes, I have them.
Okay, good. Elena Trujillo. Do we manage to have access to the Excel software there in the college, Elena? Okay, I'm gonna put a question.
Yeah. Oh,
Oh,
I
yes.
do. Sorry.
Okay, thanks. Jason Valadares.
Yes, I have access.
Okay, good. Stephen Vadhapali.
Yeah, I do.
Good, thank you. Larell. I have achieved success with the browser version. Also, can Google spreadsheet be used? No, Google spreadsheet won't work. Okay, but if I'm not even sure if the Excel in the browser version will work. Most likely, Excel, the browser version of Excel will work. I never tried before, but Google spreadsheet does not work. I can tell you definitely, it does not work. Okay, so L'Oreal is here. Nohamin, let's see. Nohamin, okay. And Alia Zavala. Okay, good. Brianna Carrillo. Yes, okay, good. So we achieved success here. Now that looks like everybody has the software. Did I call everybody, by the way? It looks like we have another student here. Unless we have a student that's double. Was everybody called, by the way? Well, okay. So let's move forward here. So the first thing we're
I
going
haven't
to.
been called.
What's her name?
Alexis
And her last name?
Quijada.
Mihada. Are you hearing my? Type your name, your full name in the chat message, please, so I can check exactly. Alex, right? Alexis. Okay, Quijada, right? Okay.
Yeah.
Okay, Alexis Quijada. Okay, so let me put it here. Now, did you get Excel there in your computer, Alexis?
Yes, I have access.
Okay, good. So it looks like everybody has, right? Audrey, the two others, did you manage to download it? Do you manage to access it?
I'm trying right now.
Okay. Now, what about Edito? Edito, Jazzy, and Gabrielle? Are you good?
Yes.
Yes? Okay. Audrey, okay, Audrey Aguilar. Okay, Audrey Aguilar here. And Gabriel Contreras. Yes. Okay, who else? Audrey Aguilar, Gabriel Contreras. Jazzy Castellano. That's good. Okay, so it looks like most of you, right? And what I want to do, okay, so go ahead and get a spreadsheet here. It's very, it's very important that you learn how to use Excel, okay? I use Excel in my private life, not just in the classroom. I use Excel in my private life. I use Excel when I'm doing research. Okay, I program Excel. I do very heavy calculations with Excel. But here we're not going to get to this point. Here we're going to do only the very simple things that the Excel offers us. Okay, and like I said, I believe I told you before, right? I have managed to discover new things doing my own research with Excel. Excel helped me discover things that no one else in the world knew about. Okay? I managed to file a patent because of the results that I got with my Excel software, the one that I programmed to come up with new ideas that nobody knew at the time. Okay? So go ahead, start your first spreadsheet. You should have a blank spreadsheet right now. And what we're going to do, we're going to plot a graph. Okay? So let me document here. Okay. First thing we're going to do, is to come up with a table that will, with a numeric table, Next, we will plot a graph based on this numeric table. Okay. Then we will get Excel to find the closest formula to your set of data, to your data set. Excel allows you to do that too, whether your data points fit into a straight line, a parabola, a hyperbole, or any other, an exponential, a log. Excel allows you to do that, okay? So, and then we're going to do more than that, but let's start with those three first, okay? And like I said, I'm assuming that you do not know anything about Excel. You never used Excel, okay? For those who have already used Excel in the past, maybe you might seem that a little bit boring, because we're going to be doing things that are very simple, okay? One of the let's keep it this way. Here you go. I'm going to put X here and Y, okay? And I'm going to use some generic numbers, okay? So let's say X value 1, 2, 3, 4, 5, 6. Okay, note see that I'm getting like six data points here. And let's say that for X equal to 1, my Y is 2. For X equal to 2, the value for I is 4. Suppose you perform an experiment, right? And you got those values that I am inputting here manually in my table. Okay? So now we have a table of data points. If you look at those numbers, you can see that there is a linear relationship between X and Y, right? If X is equal to 1, Y is 2, right? X is equal to 2, Y is 4. Y is twice X. Right from the bat, you already know there is a linear relationship between those two variables. And the equation for this graph would be something like that. Y equal to 2X, right? Just by inspection. Excel can find this type of equations. Okay, it's not always that you'll be able to find a relation for those data points. Okay, but this one is so simple that we can say, y equal to 2x. Okay, so now what we're going to do what we're going to do now, we're going to plot this graph. But before we plot this graph, what I like to do, I like to, boldface those parameters that are at the top. Okay, and even. Okay. Yeah, and then what else do I do? Just to make the table look nice. Okay, because we are doing physics here, those x and y's must have a unit associated with them. So let's say that the unit for x and y are going to be meters. Okay, let's say. So you put the unit in parentheses. And now we can start plotting the graph. Here you go. Highlight those two columns. Okay, go to insert, go to charts. The chart that we're going to use will always be this one here. Always. Don't use the other ones. It's going to be a scatter plot. Okay, scatter plot. Okay. I'm going to write that down here. Then we get this. Let's see. Next, we'll plot the graph based on this numeric table. Okay. The graph we will always use will be the scatter plot. Scatter plot. Do not connect, do not choose plots with the data, with lines connecting the data points. Okay, so let's do that. Select chart. Here you go. Now you can clearly see that those data points here are linear, right? Represents a straight line. If I was not sure that the thing would look like a straight line, now I am 100% sure that it looks like a straight line. Okay. And like I mentioned before, Excel will be able to find out what's the equation of this plot that you see right in here. But we're going to do more. Okay. In my plots, I don't like to keep a title to the graph. But you must have, every time that you plot a graph, you must label the axis. Must label the axis. And how do you do that? Okay, I'm going to show you how you do that. Look here at the top. Okay, when you highlight this table, look what happened here at the top. When I highlight this plot, this graph, I have these two other choices. These two other choices appear here at the top, right? If I unclick the graph, those two other choices disappear, right? Click it again, and they reappear. Okay, yeah, let's do that. Sean, right? I'm gonna erase the graph. Okay, here you go, Sean. Do you already have the table ready there, Sean? Do you type the table?
Yes.
Okay, good. So now go ahead and select all those numbers in the table. Step by step, right? So let's see, I'm gonna even document it here, step by step. First thing we will do is to come up with a numeric table. Next is plot based on this numeric table. So first step, highlight all cells that contain the numbers in the table. Okay, that's the first step. Once you highlight, to go to insert, right? is the second, here you go, it is the third one, the third option here in Excel. And look for charts. All charts are here, right? Go to insert, look for charts. And then look for scatter plot, okay? Select scatter plot. Okay, and then bring down your arrow and you have all those options of scatter plot. Bubbles, data points. The one that I'm going to use is the one that has no lines there. Select the one that has no lines. Select the scatter plot that has no lines connecting the data points. Okay. Step by step, here you go. Okay, and then when you highlight it, it shows momentarily, right? If I highlight the other one shows momentarily, and so on, right? Here you go. But we're going to be using this one here all the time. Most of it, yeah, 100% of the time I'm going to be using this one here, the scatter plot with no lines connecting. Now we have our the graph plotted. Can you repeat? Thank you. Just to get news. Okay, good. Now you have your graph plotted. Okay. Don't forget, we will always use the scatter plot. We will always use the scatter plot with no lines connecting throughout this course, right? Course. We will always use the scatter plot with no lines connecting the data points. Okay, do not choose the other available. Do not choose the other available plots.
Excuse me, Professor.
Yeah.
Can I ask you how you boxed in your table?
Oh yeah, that's right. Okay. Yeah, just to make it look nice, right? So I'm gonna do that all over again. Okay. So here you go. Highlight it. I'm going to unbox the table. Okay. Do you see this box here? Right on home. See that? So first you have to highlight this table where you want, and you have all sorts of options, right? Bottom border, top border, left border, and so on. What I want a thick outside border in my table to make it look nice, right? See that? And then
Yes,
I
thank you.
want, yeah? You got it?
I did. Thank
Okay,
you.
good. And then you do the same as this other one. So, it's once we do it's mathematically those boxes they don't do anything mathematically, okay? But for the view, when you look at it, it looks much nicer, right? If I want to put another line here, I'm gonna put a line to the right, and look how it looks like, right? But aesthetically, it's very pleasing to look at something like that than something that doesn't have anything great, right? It's much looks like that the head feels better when we look at something like that. Okay, so now you have your graph, right? The next thing you're going to do, let's go back here to my notes. Do not choose. Okay. Next, we will add the labels to our axis, right? Label to our axis. You will always have to do that. You will always have to do that in this course. Okay, you have to add labels, not just labels, but also the units of the labels. So, and how do we do that? We go back to what I was about to do before, right? The first thing that I do in my graph, I delete the chart title. I don't like chart title. It's just my own personal preference, right? And then you do something else. If the graph is not highlighted, is not selected, then you're going to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In my case, it's 10 options here, okay? If I highlight the graph, then 2 more options appear right here at the top. I'm going to deselect and select. See that? Deselect and select. The labels of the axis are right here in chart design. Select chart design. Okay? To the extreme left, you're going to see add chart element. And then you have all sorts of options. Axis title, see axis title, chart title, blah, blah, blah. The chart title is the one that I just deleted, right? Data labels, okay? The data point, the points in the data has labels. Let's see if I can get that. Oh yeah, I have some numbers here. See that? I'm gonna do that again. Let's do that again. I just want you to play a little bit on data labels, left of the data. See that? When I highlight that, you put a number next to the data point, okay? We don't do that in my course, okay? We don't do that in my course, but it's good for you to know because sometimes you want to see the numbers there in your graph. But what do we want? We want just to put the axis title there. See, we have a primary horizontal and we have a primary vertical, okay? Primary horizontal, primary vertical. The primary horizontal is the X with the unit in parentheses. The primary vertical is the Y with M for meter in parentheses. Everybody did that? Let's go for 2 more minutes so we can have our break, right? 2 more minutes to go. I like, my personal preference is that I always put those axes here in boldface. My personal is easier to see the numbers there. Regular, font style, bold, okay? See, it's a little bit bold. You can even change the font size. Right now the font size is 9. I don't like 9 font size. I prefer 12. Okay. And here too, I do the same. Bold. Right? Regular, bold, face, 12. And I do the same for the axis title. I'll make it bold faced. And I will increase the size, but I increase the size slightly larger to 14, okay? Here, same, bold, 12, no, 12, no, 14. 12 are the numbers, right? 1109, 1 more minute. And let's see, I don't see this number from 6 to 8. It's too much empty space here, I don't like it. So I'm gonna change the spacing between numbers. Instead of 0, 2, 4, 6, 8, I'm gonna put 0, 1, 2, 3, 4, 5, 6, 7. Okay, so here you go. I double click here and then we have this option right in here. I'm gonna put 7 here instead of 2, I'll put 1. Okay, and that's 11:10 right now. Let's take our break. Any questions before we go to the break? Break 11:10 a.m. to 11:25 a.m. Okay. So I'll see you in 15 minutes. I am back here. So let's go. Here you go. So I'm going to document, right? Here you go. When I click here, right, those two other options appear: chart design and format. First you click on the graph, chart design and format will appear as options. Chart design and format will appear as options. Okay. Click on chart design. Everything in cima. Click on chart design. Go to the extreme left, right? Okay. Add chart element. Go to extreme left, add chart element, right? Select axis title. Axis titles, primary horizontal, primary vertical. Select axis title and add the title to the graph, to the axis. Okay, that's what we did so far. And what else? What else can we do? We're not done yet. We're not done yet. There's more things that we can do. Okay, almost, every graph that we plot, most of the graphs that we plot, you will have to do what I'm going to do right now. Okay. Now we will have Excel to calculate the equation that is closest to the data point in your graph. Okay, there's a mathematical process to do that. The so-called regression equation. The so-called regression equation. Okay, so what Excel is going to do now is going to tell me what's going to be the equation the equation that's closest to this data point distribution. We are it's y equal to 2x, right? But and Excel is going to provide us with exactly this equation. And how do we do that? We find the regression equation. That's what we're doing here. Find the regression equation. Let's see, we have 27, 28. Okay, good. So what do we do? First, and by the way, this part is documented in my syllabus, okay? In my syllabus, you have that. You select one of the data points. Click in one of the data points. When you click in one of the data points, all the data points are highlighted, okay? Let's write it down. Here you go. 1. Click one of the data points in the graph. All the data points are automatically highlighted. 3. Okay, once you have all the data points automatically highlighted, you right click in one of the data points. Okay, let's go there. Right click in on one of the data points. Okay, when you right click on one of the data points, this drop-down window shows up. Okay? A drop-down window shows up. A drop-down window appears. Select add trend line in the drop-down window. Okay? Select add trend line. Go here. Select. Oops. Add trend line on the drop-down window. Add trend line. And now we have the best fit to your data points, okay? You see this line here? This line coincides with all the data points because I choose the ideal type of data points here for my graph. But we can do more than that. See here on the right side? On the right side, we have all the possible options that Excel can fit your data points. You have all possible options for your regression equation: exponential, linear, logarithmic, polynomial, power, moving average. Most of the time, we're going to use this one here, linear. And you're going to do something else too. You're going to display the equation on chart. Remember I told you Excel can calculate the type of equation that goes here on the chart. Y equal to 2x, exactly what I wrote that down, right? Oh man, let's see. Okay, here you go. And what else? I want you to display this value here, R square value. Is a very important parameter. It is a statistical parameter. Okay? So check. Let's go there. Select that, and then on the drop-down menu, on the pane on the right side, on the pane, a new window appears on the right side of your spreadsheet. Okay. Here you go. 1, make sure linear is selected and selected. Check the box. What's the box that I check? Display equation chart. Display equation on chart. Check the box. Let's see. What's the name of the box? Display R square value on chart. Display R square value on chart. You'll be doing all of that for every linear chart that you have. Hey, what happened? Oh, here you go. Okay. There's more that we can do. 11:34. We should have like 25 minutes to go. Okay, so Excel has this capability of calculating, okay, this equation, and there is a mathematical method to do that. We call it the method of the least squares. It's not the method of the least cube. It's not the method of the fourth cube, the fourth, the fourth power. It's not the method of the fifth power. It's the method of the least square. Okay, the least square. And there is a step-by-step procedure to do that. It's a rather logical procedure. It works very well. That's why we are using it here. Now, notice one very important thing. The R square value in this case is exactly equal to 1. Okay? Exactly equal to 1. I can put as many decimal places there, and you're going to see, no matter, let's see, no matter how many decimal places I put there, formatting the trend line label, okay? And you're still gonna see 1 in there, okay? I'm gonna put, let's say, 10 decimal places. See that? I'm gonna. So this one is exactly, and there is a reason why it's exactly equal to 1. There is a reason. Let's see, someone is, I'm not seeing a new window on the right. Oh, in your, okay, you're not seeing a new window on the right of your Excel. Is that right, Sean?
I also can't find how to make the trend line.
Okay, are you using a Mac or are you using a PC?
I'm using a Mac.
Okay, that's why. Okay, Mac is a little bit different, okay? Mac, you have to, when you highlight your graph, you're going to see all those 3 options here. Do you see the 3 options there on the right top?
No, it doesn't pop up.
You don't see it? Oh, that's what Mac usually do, okay? So here you go. If I see, I don't have a Mac here with me. I have a PC, okay?
I
So
I
I
do
need
see
it.
the bar on the side. I do see like the format chart area,
Yeah,
but I just don't.
yeah. Are the boxes checked? Make sure the boxes are checked, okay? And that's the way to, okay?
No, so I see the large bar that you have on the side, the format chart area. I just don't see
Uh-huh.
the line.
Let's see. Plot area. Let's see. And now mine disappeared as well. Let me check here. Let's see. Oops. Okay, let's see. Yeah.
Like
Okay.
it just
So
shows solid line, great.
okay. Do you have trend line options here at the top?
No.
No, but this pane appear on the right side. Is that right?
Yes.
Okay, you do have a window. Do you have format trend line at the top?
No.
Okay, so check. Do you have an arrow, a downward arrow here, just like I have? Check if you
No,
have
I
a,
just have the
huh? If you
I
have
just
a,
have the X. Yeah.
yeah.
No, I
Okay.
don't have I only have the X.
You don't have it. Okay. Well, I need to see what's going on there in your screen. Okay. I cannot troubleshoot that right now. So, but why don't you stay after the class, and then we try to troubleshoot that after the class. Okay.
Okay, thank you.
Okay. So let's see something else. Someone else here. I'm not seeing an option to add value. Never mind. I found it. Okay, Jeremiah. Okay, and Sean. Okay, good. So where did I stop? Okay, now I'm going to do a little simulation, okay? The reason that the R square is exactly equal to 1 is very simple. This R square is a statistical parameter that's very useful, okay? When you have a perfect fit between this regression equation and the data points that you have here, then R square will always be equal to 1. Okay, and I'm going to document that for you here. The regression equation slash trend line displayed is an approximation. It's an equation. It's an approximation. It's an equation that approximates. It's an equation that approximates. Jesus, my approximates the data points plotted on your graph. Okay. That's what it is. There is a mathematical procedure to calculate that called the least square method. Okay? Now, the R square parameter has a name. It is referred as the determination coefficient. The determination coefficient, okay? This parameter is very useful. Very useful. Again, there is an equation. There is also an equation for this parameter. There is also an equation for this parameter. There is also an equation for this parameter, which is a very useful one, This value, R square, okay, can assume values anywhere between 0 and 1. Okay? I'm going to write that down here for you. Here you go. 0 is less than R square, which is even better, less or equal. Let me put that here. Let's see here. I'm going to copy that. So the equation is formulated in such a way that you have those values for R square. Okay? R square can be greater or equal than 0 and less or equal than 1. Okay? And we have this interpretation that I'm going to give you. When R square is exactly equal to 1, comma, it means that your regression equation fits the data points perfectly. Okay? Perfectly. However, we call it also perfect correlation. We say that the equation is perfectly correlated with the data, However, on the other hand, right? On the other extreme, comma, if R square is equal to 0, this means that there is no correlation between the data points and the regression equation. Okay? Anywhere else in between, right? Anywhere else in between means that R squared, let's put that R squared here. Anywhere else in between means that the equation has some correlation with the data points. Okay? In real life, very important, in real life, when you perform experiments, you will never get a plot where R square is 1. In real life. Here we are getting 1 because this is not experimental data points. This is just like made up data points for, just for illustration purposes, okay? So most likely what's gonna happen during your experiments that you're gonna get something like that, And now I'm gonna start to play with those data, okay? With this data, okay? Instead of 2 here, you're gonna get 1.9. Instead of 4, you're gonna get 4.2, let's say. Do you see that the data are starting to get out of the line, right? Instead of 6, you're gonna get 5.8, okay? Here you're gonna get 7.9, let's say, 10.3. I'm exaggerating a little bit, and 12.2. Okay. What is not showing here is that now the R squared is no longer 1. Okay, and I'm going to redo that again, all over again for you, so you can see it. As I watch out for R square, as I start changing the data points again. Okay, here you go. I'm going to delete that. Okay, and here you go. I'm going to go back to the original data point that I have. You have perfect fitting, okay? And I'm going to do that all over again. Here you go. Yeah. And look what happens to this equation and the R square as I change the values of y, okay? Instead of 2, now I have 1.9. Okay, we start to have something here that's not exactly a 0, but something else, okay? This 1 is no longer exactly 1, is very close to 1. It just doesn't show the exact number because you do not have enough decimal places there. Let me see if I can get that number, that 10 decimal places here. Do you see that? It's not exactly y equal to 2x. It's y equal to 2x minus something else. It's not exactly R squared equal to 1, but it's R squared 0.9999, whatever, right? 329388, okay? And that's because just I changed the 1.9 here. What you see right here is far more closer to reality than the previous table that you had, okay? I put 4.1 here, okay? And the R squared changed it again. 5.8, look at 7 point, let's see, 7.8, okay? 10.3, okay, and 12.1. Look what we're getting here. Now we're getting R squared. That's not 1. It's too close to 1, very close to 1, but it's not exactly 1. Which shows that this equation that you see right in here is not 100% correlated to the data points. That's what we usually get in real life. That's what you get in real life. Okay? Play a little bit with your numbers there, and let me go back just to 2 decimal places. Otherwise, you're going to have to, oops, no, 2 decimal places is not enough. I've got to put more. 3 decimal places. Yeah, 3 decimal places. 4, right? Let's put 4 decimal places. Here you go. See, it's still very close to 2x, right? The equation is still very close to 2x, but it's not exactly. R squared is still very close to 1, but it's not exactly. Okay? But the correlation is still very strong. It's very close, 0.9978. Everybody did that? Play a little bit with those numbers here in the y. Doesn't mind, you don't have to have exactly those numbers that I have here. Okay? And have a feeling, right? Of how those parameters, the regression equation and the R square behave once you tweak a little bit your values in the table. Okay? So there's more. Let's see. 11 minutes to go. Any questions? Okay. Now, let's see. So play a little bit. So play a little bit with the numbers in your table. Use the numbers in your table and see how R squared and the regression equation slash trend line, same thing, right? Change. Okay. Now, R squared is a very good parameter to rely upon the correlation between the regression equation and the data points in your graph data points. However, this is not the final word. Something else called the correlation coefficient. Correlation coefficient. No, it's not correlation. It's another name. Sorry for that. Let me get that here. The confidence level is not the correlation, it's the confidence level. Something else called the confidence level represented by the letter CL is a better judge for the regression equation. Right? It happens that the confidence level, the CL, is a function not only of R squared, but it is also a function of the number of data points. Okay? Here you go. It's a function. So if you want to know how good your correlation, your regression equation is compared to the data points, you have to look at the confidence level. The equation for the confidence level for the CL is a very involved one. For this reason, I'm not going to show it to you. Okay? Instead, we will be using tables. Using a table that I prepared for my courses, okay? And the table is posted there here you go, let's see here, in Canvas. Let's see, where is that? My confidence level courses, this one. Link, here you go. Lecture and lab notes, confidence level is a PDF document. Okay, go ahead, download that to your hard drive. And I'm gonna get mine too. Let's see, and I'm gonna open here in my computer so you can see this table, okay? You must become familiar with this table, okay? They have other versions of this table in the internet, but none of them are good as mine. The tables that I have seen in the internet have only three columns, okay? The tables that I have seen. Mine has more, 1, 2, 3, 4, 5, 6, 7. I was able to derive the equation that allows me to generate those table, this table. Okay. It took me quite a while to do that, but it was fun. And what you see here again you're not gonna find anywhere else unless they are copying my table elsewhere. Okay. So note that you will need to learn how to read this table. Okay, all those numbers that you see right in here are the R square. I call it the critical values of R square. What you see here along the vertical direction is the number of data points in your graph. Okay, it goes all the way up to 39, but it can go to more. Ours, the number of data points in our graph is exactly 6, right? And what you see right in here is the value of the confidence level. Okay? Note that the higher the R square is, the higher the confidence level, right? R square for 5 data points. R square of 0.77148 for 5 data points correspond to a confidence level of 95%. 95% for your regression equation. However, if your R square is much closer to 1.9999619, now instead of 95%, now it's 99.99999%. Okay? This confidence level is just like your R square. It goes anywhere from 0, the extreme left of this table that's not shown here, all the way up to 1, the extreme right of this table that doesn't show here. Okay? And I want you to get familiar with this table. We're running out of time. Okay, so look at this table, play a little bit with the table when we are home. And next time, when we meet again for this lab, we will look into a specific examples how to use this table, okay? But don't forget, the important thing to have in mind is that R square is a good measure of the correlation. I'm gonna even write that down here, take home the following, take home the following. R square is a good measure of how good your regression, how close your regression equation is, how close your regression equation is to your data points. But a better measure is the confidence level, CL, which is a function of R squared and N. Okay? To find the CL, you must use the table provided in this course. Okay. Any questions? Okay, so I want to stop here and we will continue with that next time that we meet for the lab, okay? So I'm just providing the foundation for the virtual experiment that we'll be performing here in the class. Okay, so I see you next week, next Wednesday, right? Because we're not meeting on Monday. So I see you a week from now. Thank you, Sean. I see you. You too. Have a nice week, Jeremiah.
All right. See you, Professor.
See you. Bye-bye.
Thank you, Professor.
Welcome. Bye-bye.
Should I stay after class, Professor?
What did you say?
Should I stay?
Yeah. Did you figure out what was the problem with your Mac there?
I found the line, but I can't find how to input the equation into the graph.
Okay. So stay there a few minutes, and let's see. I'm gonna let you share the screen so I see exactly what's going on there in your computer. Okay, and hopefully I'll be able to troubleshoot. Okay. I'm gonna stop sharing, and I will